Hello viewers, welcome to my channel. If you haven't yet subscribed to my channel, do subscribe and press the bell icon near the subscribe button so that you get the notifications of my latest videos, and do not forget to like and share the video. We'll be continuing this chapter, light, reflection and refraction. So today our topic is about the refractive index. So before going in detail about refractive index, let me tell you what is refractive index. So refractive index is nothing but the extent of change in the direction of light that takes place in a given pair of media. We express the extent of change in the direction of light that takes place in a given pair of media in the form of refractive index, or the expression of the extent of change in the direction of light that takes place in a given pair of media is refractive index. Any of the definition you can follow, concept is the same. Now let me recall about the Snell's law of refraction, the second law of refraction that I taught you in the previous videos. So what does the Snell's law of refraction says? The ratio of sine of angle of incidence to the sine of angle of refraction is a constant, right? It is a constant. Now this constant is the refractive index of the second medium with respect to the first medium. Alright. Now let me go a little bit more in detail about the refractive index. So I told you about the definition of refractive index, and I just recalled about the Snell's law of refraction and told you that the constant that you get is the refractive index of the second medium with respect to the first medium. Now refractive index is an important physical quantity. Alright. Now light propagates with different speed in different media, right? So the speed of light is the fastest in vacuum. Okay. Speed of light is fastest in vacuum. And the speed of light in vacuum is 3 into 10 to the power 8 meter per second, or you can write in this way also, 3 into 10 to the power 8 meter per second. Both are the same. Both are the same. But the speed of light is fastest in vacuum with a speed of 3 into 10 to the power 8 meter per second. In air, the speed of light is just marginally lesser than vacuum, but it's almost the same. Alright. Now, the value of refractive index for given pair of media depends on the speed of light in different media. Alright. Depending on the speed of light in different media, you get the refractive index. Now let's just consider this to be glass. Okay. This is glass and this is air. I take this to be my medium number 1. This is my medium number 2. Air is medium 1, glass is medium 2. Alright. Now the incident ray comes like this from air. This is the incident ray and slightly bends in glass because they are little optically, this is optically denser medium, this is optically rarer medium. Alright. So the direction of propagation of light changes in different media, right? First let me draw the normal. Normal, the perpendicular line is my normal. Okay, n dash is a normal. So where would the refracted ray bend? It would bend towards the normal. So it will bend something like this. This is my refracted ray. Alright, this is the incident ray, this is the refracted ray. Alright. Now this ray, just consider that the ray is traveling from medium 1 to medium 2. Okay. Now I take V1 to be the speed of light in medium 1 and V2 to be the speed of light in medium 2, that means in glass. Now the refractive index of medium 2 with respect to medium 1 is given by the ratio of the speed of light. Let me write it like this. The refractive index of medium 2 with respect to medium 1 is given by the ratio of speed of light in medium 1 to the speed of light in medium 2. Okay, the refractive index of medium 2 with respect to medium 1 is given by the ratio of the speed of light in medium 1 to the speed of light in medium 2, which is also equal to, I told you that the speed of light in medium 1 I have taken it as V1 and the speed of light in medium 2 I have taken it as V2. It is equal to V1 by V2. Alright. Now similarly, in the other way, if I take, I just consider that in the same argument I just take that the refractive index of medium 1 with respect to medium 2, how would I express? How would I express the refractive index of medium 1 with respect to medium 2? I have to write this in 1, 2. The refractive index of medium 1 with respect to medium 2 is given by the speed of light in medium 2 by speed of light in medium 1. So here I will be writing V2 by V1. Just follow the words properly. If the question is find the refractive index of medium 1 with respect to medium 2, then you have to write N12. Here you should write speed of light in M2, that means in medium 2 by medium 1. If the question is find the refractive index of medium 2 with respect to medium 1, then you will be writing N21. Then there you will be writing speed of light in medium 1 by speed of light in medium 2. That time you will be writing V1 by V2. Just note the words properly. Look at the question properly. Now another case, this was about refractive index. Now I'll tell you what is absolute refractive index. Now if medium 1, okay, if medium 1 is vacuum or air, okay, if medium 1 is vacuum or air, then the refractive index of medium 2, it can be anything, it can be glass, it can be water, whatever, okay, but medium 1 should be vacuum or air. If medium 1 is vacuum or air, then the refractive index of medium 2 is considered with respect to this vacuum or air. This is called absolute refractive index. Okay. See, if medium 1 is vacuum or air, then the refractive index of medium 2 is considered with respect to the vacuum. Now, this absolute refractive index is just expressed as N2. Now, let me consider that C is the speed of light in air. Okay, I just take that C, I consider C is the speed of light in air. Then I consider V to be the speed of light in some other medium, in a particular medium. Alright, then the refractive index of the medium Nm, because this is the second medium, I told we'll be just expressing it as N2. So here I have taken it as just medium. So I have written Nm, okay, not N2. Here it's Nm, refractive index of the medium Nm is given by speed of light in air upon speed of light in the particular medium. This is your absolute refractive index. Now this absolute refractive index of a medium is also just known as its particular refractive index or its refractive index. Its refractive index. I mean the refractive index of the particular medium. That means the refractive index of the medium. The medium. It's not like other sums that you do. In other sums we may compare glass and water or kerosene and glass. It is different, right? But over here we consider it with air. Water and air, glass and air, or kerosene and air, diamond and air, sapphire and air, some medium along with air. We compare this with air, okay, any medium with air. That time it is just known as refractive index of the particular medium. Alright, water's refractive index or the refractive index of glass, whatever it might be. Okay, now so I end my video over here. If you have any doubts, to ask me in the comment section, or if you want me to make a video on a particular chapter or on a particular topic from any subject, do tell me in the comment section.